Hello everyone, this is the ArcGIS Pipeline Referencing Introduction and What's New session. My name is Nathan Easley and I'm the Product Manager for ArcGIS Pipeline Referencing.
And I am Deblin Das, a senior software developer in the pipeline referencing team.
Pipeline Referencing is an enterprise linear referencing extension designed to extend linear referencing capabilities for the pipeline industry across the ArcGIS system. It includes tools within ArcGIS Pro to support centerline and route management, along with a suite of geoprocessing tools to support configuration, data loading, and analysis. Also included is a REST API within ArcGIS Enterprise, which supports editing, sharing, and analysis of your linear reference data, which also opens up the ability to extend linear referencing capabilities into third-party applications. Pipeline referencing also includes a web application called Event Editor, which brings event characteristic and asset editing, along with data QC on those events, into a web experience. So let's discuss the information model for pipeline referencing. There are a few feature classes and tables that make up the minimum schema required by pipeline referencing. That includes the centerline feature class, which is just a Z-enabled polyline that provides the geometry for linear referenced features. Calibration points are a point feature class with specific measure values at the location of each point. Those measures are used to support the interpolation of measures along all linear referenced routes. The centerline sequence table connects the centerline geometry with the calibration point measures to create routes. And those routes are simply Z and M enabled features. Each route has a unique identifier in order to ensure the correct centerline geometry and calibration point measures are applied. Routes are grouped together and stored in a feature class called a network or an LRS network. Events are the features representing those characteristics or assets that are linear referenced on top of the routes in the network. All of these minimum schema items are normal feature classes and tables within the geodatabase. To support the different types of linear referencing commonly used in the pipeline industry, we've created different types of networks. Continuous networks are collections of routes where each route has no relationship to another. Each route has its own unique identifier, along with its own specific geometry and measures. If your linear referencing requires the use of engineering stationing, the line network type would support those requirements. In a line network, each route has a unique identifier, its own geometry and measures, but those routes are also grouped together under a concept called a line in order to support concepts like equation points. A derived network is a continuous measure representation that's built off of a line network. The derived network dissolves all the routes that are on the same line within a line network into a single continuous measure route geometry. This really simplifies supporting analysis and reporting using this linear reference data. There are three different types of events that we support as well, which again are those characteristics and assets that are linear referenced on a route. Point events, such as anomalies or assets like valves. Line events, such as DOT class or operating pressure. And a different type of line events that span routes that are used with line networks where a single characteristic could span across multiple routes that are contained on the same line. This last year, we've also added enhanced support for Z-aware and vertical pipes, opening up support to visualize and edit linear reference data in both traditional 2D maps as well as within 3D scenes inside of ArcGIS Pro. Z-values that are contained on centerlines are propagated onto the routes that are created from those centerlines. In 2D, a vertical pipe or a vertical segment on a pipe wouldn't show the vertical segment and the measures along those vertical sections. With these new capabilities that we've added, you can now edit the pipes in 3D, ensuring the measures are correctly applied for the vertical segment along with any other parts of the route. Pipeline referencing also integrates with the utility network for those users that want to take advantage of both the linear referencing and connectivity modeling capabilities provided by the utility network side by side. Historically, pipe systems have been siloed off into three segments: gathering, transmission, distribution. There were different methods for data management, different software solutions, and even different databases for each of these segments, which was highly inefficient. This siloing prevented operators additionally from being able to look at their entire system within a GIS for both linear referencing and connectivity modeling. With the work that we've done to integrate pipeline referencing with the utility network, users can now store all of their data for their entire pipe system in a single geodatabase and utilize both the linear referencing capabilities of pipeline referencing and the connectivity modeling capabilities of the utility network on this single data set. While the utility network and pipeline referencing have different information models, there is a common integration point for the two models when they're used side by side. The pipeline feature class in the utility network and the centerline feature class in pipeline referencing both model the geometry of a pipe. If you want to integrate and deploy pipeline referencing and the utility network together in a single geodatabase, such as UPDM, you would model that single feature class that would serve as both the pipeline referencing centerline and the utility network pipeline, removing any redundancy or duplication of this geometry data for the pipes. Now I'll turn it over to Devlin to discuss our service-oriented architecture.
Now that we have an idea of what the information model in APR looks like, let's have a look at how it is architected inside the ArcGIS ecosystem. But before we get into the current state of the architecture, it might be good to have a refresher on its state before we move to ArcGIS Pro, that is the ArcMap-based architecture. Typically, we would have an enterprise geodatabase backing this architecture in production deployments. Though you could always use a file geodatabase and work locally, we will leave that out for the purposes of this demo. The geodatabase would have been traditionally versioned, with the default version representing the true state of data and multiple child and grandchild versions representing the temporary states in a multi-user editing environment. The geodatabase would be referenced directly in ArcMap, which would also need to have the APR extension installed separately. Activities such as create and retire route would directly hit the geodatabase from the desktop environment. For event editors, the data would also need to be published to an ArcGIS Enterprise instance, which would need to have the APR extension for server installed on it. The enterprise deployment would expose the event editing REST endpoints, which would be consumed by our event editor application. As you can see, the consumption patterns for different workflows such as route and event editing in this architecture were developed and maintained separately. Moreover, such an architecture causes bottlenecks when it comes to third-party development on APR, as well as scaling the multi-user editing experience on a traditionally versioned enterprise geodatabase. For ArcGIS Pro related deployments, this architecture looks a little different. The enterprise geodatabase is now branch versioned and connected to the enterprise deployment. This is achieved by publishing your data using ArcGIS Pro as an initial setup process. This exposes our new REST API, which is similar to the ArcMap-based REST API, but exposes a lot more capabilities, including route editing and asynchronous geoprocessing tools. This API is the cornerstone of most LRS consumption in this new architecture, and it is used by ArcGIS Pro, Event Editor, and third-party applications that you may decide to build. Note that you need to do LRS configuration through Pro when it is directly connected to the geodatabase. You may also do some data loading initially through a directly connected pattern, but in most regular use cases, you will use Pro connected to the LRS feature service coming from Enterprise. So what are the advantages of this architecture? Well, for a start, it streamlines administration by removing database connection files out of the picture. It expands flexibility and helps us make a singular point of entry to the LRS stack, which can be consumed by any software that understands our REST API, including our extension in Pro. Note that you do not need to install separate extensions for Server and Pro, as they come built in with the software and are merely enabled if you have the appropriate licenses. Let's take a quick look at how the REST API can be accessed. It remains the same as before for the most part. You refer to your deployment name, and from there you go to the service name, and finally under the extensions hierarchy, you will find LR Server, which was previously called LRS Server for ArcMap-based services. We have been expanding the new REST API over time, and I'm pleased to say that it is now home to more than 30 endpoints, covering everything from route editing, event and network-based query operations, geoprocessing tools which run asynchronously, metadata information about LRS layers, and conflict prevention. Using these endpoints, you could build LRS companion apps or capabilities catering to your own custom requirements. We will actually see a demonstration of the raw linear referencing REST API, but before that, let's take a quick peek of how APR looks inside of Pro. When you add an LRS feature layer, such as the network or an event to the map, you should see the location referencing ribbon show up. This ribbon houses the tools needed for a variety of linear referencing workflows, such as route editing, calibration point editing, centerline editing, conflict prevention tools, and a few route identification utilities. Let's focus on a few of the route editing capabilities that APR provides. We have Create, where you can create a new route from input center lines, or in other words, pipes. There's Extend, which allows you to extend an existing route with a new center line. With Retire, you can retire part or whole of an existing route. Cart realignment is typically handy when you need to make corrections in your pipe geometry after receiving more accurate representations of your GIS data, which may be through aerial imagery or field data collection. You edit the geometry of the center line, and that update is automatically pushed to the route and calibration points, and they snap to the updated centerline geometry. Realign, or reroute as it's sometimes more commonly known as, allows you to realign a part of your route with a new centerline, thus providing a way to introduce new construction on an existing pipe. In one variant of the realign, you can retire the old portion of the route. In another, you can convert the old portion into a new route representing an abandoned pipe, which allows you to continue calculating mileage for it. We also have two typical use cases of reassign. One where an existing route can be split into two routes, and another where portions of multiple different routes can be merged into one. Now let's have a look at these Pro tools and understand how the linear referencing REST API is driving their functionality. So, I have ArcGIS Pro 2.8 open here, and there are some LRS feature layers in the map. Note that this data represents a combined pipeline referencing and utility network deployment. So the LRS center line is basically the pipeline line feature class. To verify that, let me look at the layer properties for that feature class. I'll scroll to the location referencing section. We can see that this is indeed the LRS center line, and we can also see the LRS fields associated with it. In this map, we also have a couple of LRS networks, such as the continuous network and the engineering network, the calibration point feature class, a few LRS events, as well as some utility network feature classes, such as the pipeline device and the pipeline junction. All of these layers are coming from a feature service which was published to Enterprise 10.9 from Pro. We can verify that from the source section in the properties. Let's open up the properties once again. The URL tells us that it's coming from an ArcGIS Enterprise setup. Let's go over to the Data Source tab. As you can see, the data is coming from a branch version that I've created for the purposes of this demo. In branch versioning, regular version management is done through services. This allows us to create, delete, and switch versions while using a feature service. Now let's go to the location referencing ribbon, which will be enabled whenever you have an LRS layer in the map and an appropriate license. We can see the tools that I was talking about earlier. We also have a new experience which we debuted a couple of releases ago, which is the LRS hierarchy. This is accessible from your ribbon, as well as from the catalog pane when you expand an appropriate database connection file. Once you open it, you'll be able to browse the LRS schema for the layers in the current map in a hierarchical way. Let's get back to route editing. Here, we see a transmission pipe on the left, which is the blue polyline, and it already has a route on it. But the pipe following it does not. This pipe might be labeled as distribution because of operational reasons, but has a high enough pressure to be termed as transmission for regulatory purposes. Previously, it was difficult to unify the management of these linear referenced assets inside the same organization, and may have led to disparate asset management in siloed databases. Well, not anymore, because you can manage transmission and distribution data in the same system. Let's create a route on top of this transmission operated distribution pipe. Let's open the Create Route pane first. It tells us to select one or more center lines. Let's choose this pipe. Let's assume that this pipe was put in at an earlier date. Let's provide a line and a route name. Note that the measures were auto-populated based on the pipe attributes. We'll now hit Run and wait for it to complete. Let's identify the new route and double check what we just did. As you can see, this is the new route that we created with a starting measure of 0 and an ending measure of 365 feet. One thing that we haven't talked about in this demo is the backing REST services which are actually performing all the business logic. What you just saw was nothing but ArcGIS Pro executing the linear referencing REST API and then updating the map with the results. This is something that we can test from a browser as well. Let's save our edits and zoom over to another location. We have around 5 center lines here, and let's say we want to create a route with all of them. Instead of doing it from Pro, let's try to do it using the raw REST API from a browser. Here, we are in the services directory of ArcGIS server. Let's navigate to the LR server extension from the map server of our service. From there, we will go to the apply edits operation, which is the entry point for all LRS route and event edits. I have the edits parameter formulated already, so let me put that. I won't go into details about the format, but some parts are self-explanatory, such as we are doing a create route here with some centerline object IDs. We are providing the from and the to measure, and we are providing some attribute information, such as the route name and the line name and the date. Let's give the GDB version that we were working in, and let's run this. As we can see, it was a successful edit. Now, let's go back to Pro and check if we can see the new route. Back in Pro, we will refresh our version and see what happens. As we can see, this is the new route that we created. Identifying it should show us the information that we provided in the REST API. This demonstration shows that the meat of the LRS business logic has now moved behind the REST API, and it provides a lot of opportunities on what solutions third-party developers can create by utilizing the API. Last but not least, let's look at a simple realignment. We have come back to the first route that we had created. It turns out that there has been new construction since, which is represented by this blue transmission pipe. And we need to realign the existing route to account for the installation. Let's bring up the Realign pane. Notice that once we select the center lines for the realignment, the pane automatically fills up the information based on the route that the center line was touching. We will uncheck the abandoned route creation for this edit. The measures at the ends of this new pipe is different than what used to be the case in the route before the realignment. So we will be creating 2 equation points as a result of this realignment, and our existing line will have 3 routes instead of 1. In the next pane, the software shows us the section that is going to be retired. Next, we give a name for the new route in the Realign section. We also give a name for the new route in the downstream section. Now we'll hit run and wait for the result. As we can see, there are 3 resultant routes. One here, and one here, and one here. And there are 2 equation points, here and here, formed by 2 pairs of calibration points. LRS is also temporally aware, and we have from and to date columns in our datasets to achieve that. Based on the dates you provide in the edits, both the pre-edit and the post-edit route states will be preserved in the geodatabase. This is apparent through the time slider in Pro. Right now, it's at June 2021, and hence we are seeing the current representation of the route. Remember that we had kept the default current date during the realignment edit, which was also June 2021. So if we go back before this time, we should see the original representation of the route. And if we move forward to on or after June 2021, we should again see the route representation after the realignment. So we saw a few Pro editing tools in action, as well as the backing linear referencing REST API. Now let's move on to LRS event behaviors. Event behaviors are rules configured for individual event feature classes, which tell the software how an event on a route should update in both shape and measure after an LRS route edit has taken place. Stayput preserves the geometry of the event, but updates its measures in accordance with the new measures on the route. Move does the opposite by preserving the measures, but updating the shape to line up with the new locations of the existing from and to measure on the event. Retire is useful for events such as DOT class, where the route edit would require recalculation of the impacted event. In the picture, as the event fell within the range of the edit, it would be retired on the to date of the route edit. Let's have a look at event behaviors in action. For this demo, I have a new map and backing data. This is also a pipeline referencing feature service, but it isn't integrated with the utility network. Now, instead of looking at this data from a 2D map, like we are doing right now, let's go to a 3D scene. As Nathan has already mentioned, APR now supports editing in a 3D scene, and you can totally take advantage of the added dimension for visualizing your vertical or simply Z-aware pipes. Here, we have the same feature service that we were seeing in the other map, but in a scene. The symbology is a little different, but I've tried to keep the colors the same so that you can understand the similarity with the previously shown map. The network is shown in pink, the center line is shown in blue, and the calibration point as green spheres. From a 2D perspective, the route looked flat, but the 3D view obviously reveals much more details about its form, as we can see that the route and the center line has vertical sections. Let me turn on the visibility for a few event layers. we have operating pressure. This one has an event behavior of stay put, which means the software is going to preserve its geometric location but update its measures after a route edit. Then we have DOT class, which is set to retire. So a DOT class event which is impacted by a route edit will get retired. Finally, the inspection range event feature class has an event behavior of move, and the software will preserve its measures but may update its location once event behaviors are applied. So we have these three events from three different event layers, all with different event behaviors. Now let's make a route edit. And for this scenario, I'll choose to do an extend with the blue center line at the beginning of this route. Let's bring up the extend pane. I'll select this center line. I'll provide a date. I'll choose the route that we are going to extend. And for this edit, I'm going to turn on the recalibrate route downstream. What that'll do is the measure that the centerline accrues will get added to the route, which is downstream of the centerline. So let's run this and wait for it to complete. With the route extension complete, it's important to note that we have also enhanced our collection of tools to support 3D and vertical geometry cases. You can see that by using identify routes on different portions of a vertical section, and it should provide you with different measures. Let me identify the beginning of this vertical section. That's around 147 feet. And then let's identify near the end of the same section, and it should give us a higher measure. Now, let's run the event behaviors and see what happens to the events after this extend route. We'll open apply event behaviors from our toolbox. We'll provide the engineering network as the input and let it run. This tool will read the edit logs for the input network, find out the new edits that were made, and update the events that were impacted by the edits. As the extend route edit changed the measures on the route, you can see that the green inspection range event moved up to the front to be in line with the new measures. The orange DOT class event got retired, and we cannot observe it anymore because of the time the time slider is currently set at. The gray operating pressure event, however, stayed at the same place, and if you would check, we would find out that its measure has gotten updated. Pipeline referencing also comes with a suite of geoprocessing tools. These are accessible from the location referencing toolbox in Pro, or as I had mentioned before, most of them can also be accessed from the linear referencing REST API as asynchronous geoprocessing tools. In fact, most of the Pro side tools ultimately call our REST endpoints to perform the business logic. The collection of LRS tools can be broadly divided into three categories. There's LRS configuration. These tools need to be executed when Pro is directly connected to the geodatabase and would typically be used to perform LRS-related administrative tasks, such as creating and/or registering an LRS network or an LRS event. Then there's data loading tools, which can be used to bulk load LRS data. For example, in a scenario where a chunk of data needs to be transferred from one system to another, you can perform supplemental loading of route or event data instead of manually digitizing individual records. There's also a set of LRS tools which help in transforming the data. These tools may modify the LRS data in place and help to keep a part of the LRS stack up to date or in sync with other parts. We saw an example of this in apply event behaviors, as we executed the tool to bring the events in alignment after a route edit was performed. These tools may also produce data products, which can be used separately for analytical purposes. Let's take a look at one such tool. So we are going to talk about overlay events. This tool performs something called dynamic segmentation. It takes a list of event feature classes which possibly have different units of measurement, translates them to the target network's unit of measurement, and then segments the route features in that network into sections, each of which have common attributes pulled from the event. Note that the original route is left untouched and an output dataset is created. Let's take a look at an example. The blue route here comes from the target network, and the class location and quoting event feature classes have events which align with the same route. In this case, the output will have three segments of the original route. One, which has the class 1 and corrosion properties, another, which has class 2 and corrosion properties, and the last one, which has class 2 and insulation properties. This provides a way to visualize independent spatial portions of the route, which possess a unique combination of characteristics. With that, I will hand it over to Nathan to talk more about our event editor application.
Thanks, Devlin. Let's talk a little bit about the event editor application. So Event Editor is a web application that's built using the JavaScript API and HTML5. It's powered by the Linear Referencing REST API and supports users being able to create and maintain linear and point events, as well as editing their attributes. You can also make selections based on geometry or attributes, and you can also perform quality control to look for linear referencing data conditions like gaps, overlaps, or invalid measures that could be on your events. Your data can come in from the field in a variety of location methods. Event Editor supports being able to add new events using a variety of methods such as route and measure, stationing, referencing and offsetting from locations like intersections or even other events like welds, as well as from coordinates that come in from the field. So let's go ahead and take a look at Event Editor in action. So here we are inside of Event Editor. Before we get started adding any events, give you a quick tour of some of the capabilities. Up top, you see there's three tabs. Right now we're on the Map tab, where you can do things like explore and interact with the map, do identify, or even do things like changing the base map or the layers that are turned on in your map. If we go to the Edit tab, you'll see there's the ability to manage edits because we'll be inside of an edit session, as well as to do versioning, as well as selections, and then being able to edit the actual events themselves, so creating new ones as well as event replacement. And if we look at the Review tab, there's the opportunity to do things like checking events for QC, as well as markups on the map, or being able to do measures. In this case, we'll go ahead and start with our first edit. Right now, Devlin in a previous demo showed that he created a new route here. Now that route was created recently and just got into the GIS, and it's actually had its first inspection and already has an anomaly that we need to put. So that anomaly is modeled as a point event here, so I'm going to need to add a point event for an anomaly. So I'll open the Add Point Events widget, choose my event layer, it chooses anomaly for me, choose the network that it's going to be associated with, and then I'm going to choose the actual route on the map here. I'm going to choose the input method, so it's going to be based on the route and the measure that came in from the inspection was 47.51. The date of that inspection was the 21st. And I'm going to click Next, and now I'm going to start to populate all the attributes that go with this anomaly that's going to be added. Now I could go in and populate the rest of these, but I'm just going to populate these few. I'm going to click Apply. And it actually opens an edit session and begins to add the anomaly. So we get confirmation now that the event's been added, and as the map refreshes here, we'll see the anomaly actually appear on the map where the red X was that represents the measure 47.51. So now the anomaly appears. Since this pipe was recently created in the LRS, we also need to add all the line events, such as class and operating pressure, onto this newly created route. We'll use the Add Linear Events widget to do this. But before I show you that, I want to go ahead and configure an attribute set. Attribute sets allow us to create a collection of event attributes from multiple event layers. Using these attribute sets inside of the Add Linear Events widget, we'll be able to create multiple events using one operation. So first, let me go ahead and configure my attribute set. So I open to modify the attribute sets. You'll see that there's a default attribute set already in place. In this case, I want to create a new one. So I need to give it a name. Choose the network it's going to be associated with, as well as how I'm going to input it. So I could do route and measure like I have here, or a variety of offsets, or even coordinates or stationing. In this case, I'll take the defaults, which is route and measure. And I'll click Save. And now I need to actually choose which of the event layers I want to be configured with this attribute set. So I want to use my DOT class. So let me go ahead and put that into a new group, as well as the operating pressure. And so we can see all of the attributes associated with those two layers are now in this attribute set. I'll click Save and then Close, and you'll notice that it's now the active attribute set for when I go to open the Add Linear Events widget. So now I click to Add Linear Events. So the widget opens, and now I have the choice here that I need to choose the line, as well as the from and to route IDs, as well as their location methods in order to add my new linear events. So I'll go ahead and choose the first route. And I'm going to actually choose that it's going to be at the start of the route. So I'll choose to use route start, 0, and you see that I get the X on the map for my to route. And now for the method here, I have the choice again that it defaulted to route and measure. But in this case, I actually had coordinates come in from the field that I'm going to utilize. So I'll change the method here to coordinates. It's going to use the spatial reference of the map that I'm using. So I'll go ahead and type those in. It shows that new location on the map, as well as the measure. I'll choose the date that these events started. And I'll choose some additional options to make sure that they actually are located correctly. I click Next, and not only does it show me the DOT class event that I can create, but I also calculated that and created that operating pressure range as part of my attribute set. So I'll be able to create both of these events here at the same time. So for the DOT class, I'll just quickly add a couple attributes, and same thing for the operating pressure. Click Apply. And we see that the new event was created. And what we see is the new event is also added to the map. In the Add Linear Events widget, what was the to measure, our coordinates, is now the from measure, which allows us to continue adding events down the route. So the next example I want to show is a case where an attribute on an existing event has already changed. So in this case, I'm going to go to a different bookmark. So now I'm in the location where I'm going to update the attribute for my existing event. In this case, I need to update the operating pressure event and its pressure value. So I'm going to go to the Edit tab, and I'm going to choose that operating pressure range, as well as the rectangle selection tool to select that existing event at the location. Now here I'm going to make a quick change to just change the pressure value from 275 to 300. Make that change and click Apply, and then it will save and apply those edits within the edit session. So the event's updated and the edit goes through. While I'm in this area where I've made this update, I want to do a quick QC check to make sure that there are no gaps, overlaps, or invalid measures. In order to do that, I'll go to the Review tab and open Check Events. So I'll choose the engineering network. I'll choose the route that I was just working with for that operating pressure event. And then beyond that, I have the choice, do I want to do a specific measure range, or in this case, I'll leave both the from and to measure empty, which means I'll check it for the entirety of the route. I also have the option to choose how do I want to check the event layers. Do I want to check all the event layers that are in the map, a specific attribute set, or in this case, I just want to check the operating pressure because that's what I was working with. I do want to detect for both gaps, overlaps, and invalid measures. And so now I'll run the check. And what comes back is that I do have a small gap here, a very small one that I need to go and address. So that was a quick overview of Event Editor. Now back to the presentation. So let's take a look at our product roadmap. Our team is focused on adding enhancements to data loading and editing for operators that are taking advantage of the combined pipeline referencing and utility network deployment pattern. After that work, we'll be focused on bringing in event editing capabilities in ArcGIS Pro to provide users that additional flexibility in how they do the editing and maintenance of their events. And beyond that, we'll be looking at adding analytics and reporting capabilities onto your linear reference data that's managed by pipeline referencing. Below are some additional resources if you're ready to get started or you just want to learn more about pipeline referencing. We encourage you to take a look at all of these links. So that completes our presentation. We'll now go on to the live Q&A.